Yeah, we are here at the MOXA Center in New Delhi at Smart Grid Expo, and we are talking about the MOXA's incorporation. We are talking with Mr. Daniel Lai. He is the product manager, product marketing, embedded computing division from MOXA. Yeah, welcome, Mr. Daniel.
Hello, everyone.
So, how do you define the intelligent substations?
I think the basic element of a digital substation is the primary device intelligence, and the secondary device Ethernet networking. And finally, they will direct, communicate, and control with the computers. And at the end, they can achieve the unmanned operation.
So, what is intelligent about it? What is intelligent?
The intelligent means the devices, they can think by themselves and they can do something by themselves. They can have some judgment by themselves. They can do some action in advance, and then they show feedback to the control center or the operation system. Moreover, the operation system can also give a simple command to the intelligent devices, and they can suddenly to have an action immediately.
So, what are the benefits of having the intelligent devices?
I think this is the trend, because if we like to achieve substation automation, then all the equipment should be thinking by themselves, and they can do some action by themselves. Then we can achieve the smart grid and to manage all devices through the internet, even through the internet.
So, what are the basic features of an intelligent substation?
The intelligent substation, one, the device intelligent, and they can connect it to the network, and they can communicate with computer directory, and moreover, the intelligent devices can communicate each other, and this will dramatically save the time to make the decision, and they will make the substation operation more efficiently.
What is the MOXA is proposing for smart substations?
Actually, MOXA, we are professional hardware vendors, and we design, manufacture the communication devices. For example, the substation switches, the serial to Ethernet device server, and we also have the I/O, industrial camera, and we also have industrial wireless access point. And moreover, we have industrial grade the substation embedded computer.
So, how does the smart substations maximize the system availability then?
I think the trend of the smart substation is to introduce the predictive maintenance strategy to increase the life cycle of the substation control systems. I think when we say about the system reliability, it's not only the reliability of facilities, but also the reliability of a control and management system. And as you have known, the control management system is running on a computer. Therefore, when we shall see computer, we shall treat computer as a critical part in the substation. And we should not use the normal consumer computer in the substation.
So, the smart cities or the smart world, or when we talk about the digital world, so it has several benefits, but it comes with the challenges as well.
Yes.
Right. So, what are the challenges you are facing while protecting the control systems?
The challenge of the control system is, we'll talk about the control system on smart substations. Then they have three elements. Okay, we can categorize into, for example, the first one is performance. The second one is the reliability. And the third one is the availability. And the final one is the manageability. And the challenge is how to combine these four elements into the computer. For example, for the reliability, then we must use the IEC 61850-3 compliant computers. In order to achieve this certificate, then it must be the fanless computer. And we also talk about the performance. How to combine the high performance but fanless into a computer, that's the challenge.
What does it take to upgrade these old systems to a new system, right? And how the MOXA is contributing towards that?
MOXA, we design the computers for especially for the power vertical market. Therefore, we have a firstly we use MOXA patent heat dispatch technology, so we can achieve the fanless and wide working temperature from -40 to 70, which is compliant to the IEC 61850-3 and C3 requirements. And we also can achieve the high performance to use the i7 CPU quad-core CPU. To use the i7 quad-core CPU in our fanless basic computer.
So what are the changes has brought about by maintenance due to the introduction of digital substation automation systems?
I think for the challenge on the substation is we just bridge the IA domain know-how with the IT technologies.
What are the long-term strategy for maintenance that should be taken into account, considering the technical and the economical aspects of these systems?
Traditionally, they have three types of maintenance. Typically, they have three types of maintenance. The first one we call is relative maintenance, and this is the concept to run to fail. And I think most of the traditional substation they are using this kind of maintenance strategy. But run to fail must have a longer downtime, and so next step they move the relative maintenance to be the reactive maintenance. The reactive maintenance is the so-called time-based maintenance. So the operator they may schedule half-year or yearly maintenance to the component but I think this is not enough. Therefore, the trend is to introduce the predictive maintenance into the entire substation automation. But unfortunately, most of the operation they introduce this kind of maintenance strategy on the facility. They forgot to include the control system. What I mean is the computer into the predictive maintenance.
So what is the predictive maintenance?
Predictive maintenance is kind of a condition-based maintenance. The system they will periodic to monitor the status of a computer, and they will report the unhealthy event to the operator. And this will benefit the operator or the maintenance engineer to schedule the maintenance activity at the time they like, and the time is to have a most lower downtime.
So, and what is the advantage of predictive maintenance provided over the other maintenance approaches that we have today?
I think the benefit of the predictive maintenance is not only to reduce the downtime. The best benefit of predictive maintenance is to eliminate the downtime. How can we say that? That's because when we monitor the status of your computer, then we can report the unhealthy status to the operator. Furthermore, predictive maintenance can let the operator to set up the criteria of the status on each key part of the computer. Therefore, when the operator receives the alert, the computer is still working well, and the operator still have enough time to schedule their maintenance activity. Moreover, the predictive maintenance also can help the operator to enhance the operation of their application. For example, the fault recording, the PMU, so on.
What are the technology tools applied to that predictive maintenance?
To achieve predictive maintenance, we can use the existing sensor inside a computer. For example, we can enter the BIOS mode to find out the hardware status, and we can also use the performance monitoring tool on the operation system to find out the system performance. But unfortunately, these two tools cannot be worked by themselves, and we definitely cannot enter the BIOS mode operating system because we have to shut down and reboot again. And of course, we will not have time to sit in front of the monitor to look at the system performance anytime. Therefore, the What we need is we need a tool to proactive monitor the hardware and the software and the system performance. And once them is expected to your expectation, then she'll send out alert to the operator. Unfortunately, there's no existing tool on the market for the customer to use. Therefore, that is also the benefit that MOXA delivers to our customer. We native support ready-to-use tool called Proactive Monitoring on our computer, and it's free to download on our website to help customer to achieve the predictive maintenance. And what we do is we will allow customer to set out the criteria on the key part status. For example, we can monitor the status of storage capacity, and we can set criteria. For example, if the capacity is more than 80%, then we will send our alert to the operator. And I think this function is benefit to the fault recording application, because fault recording, they store all the information on the fault recorder. Once the storage is full, then there will two things will happen. The one the new information coming will be discarded, or the new information will override the old information. I think both of these two things we are not happy to see. Therefore, when the storage is reached 80%, we send alert to the operator. During this time, the computer is still working well, and for the operator, the benefit is they have much time to schedule their maintenance activity.
And what are the challenges before the maintenance engineer while doing the predictive maintenance?
Just like what I say, the challenge is there is no ready-to-use tool on the market right now. Therefore, if customer they like to have this kind, if customer they like to have a predictive maintenance on their computer, they have to implement this tool by themselves. For the customer, if they have software capability, they have to invest the engineer and resource to development this tool. When it comes to customer, they don't equip with the software ability, then maybe he should pay the money for the third party to customize this tool. But if you use MOXA computer, then the tool is ready.
So what kind of investment is required for doing such maintenance approach, while adopting this maintenance approach?
Just like what I mentioned, all MOXA embedded computer is native support the proactive monitoring function. Therefore, the only effort to you, the only investment to you is just to buy in MOXA embedded computer.
You just presented your paper here at Smart Grid Summit. So
Yes.
can you highlight on the papers that you have presented?
I think the key point of my presentation today is all of the device is intelligent on the substation automation, and those intelligent devices were connected to communicate or controlled directly by computer. So we should treat computer as a critical equipment on a substation, and we should introduce the good maintenance strategy to computer. And finally, we should select the right computer to increase the reliability.
So thank you very much, Daniel. Thank you for your time.
Thank you.